Hello, everyone. My name is Moshe Nave from the SAP community team. Today, we have another SAP community call about how to use the Open API client generator of SAP Cloud SDK. And we have Matthias and Jordan from the SAP Cloud SDK development team. Please take it away.
Thank you, Moshe. Hello from my side. This is Jordan from the SAP Cloud SDK team. As already announced by Moshe, today we want to give you a brief overview on how to use the new OpenAPI client generator that will allow you to generate client libraries for accessing REST services, for example. Before we start with the content and the presentation, please keep in mind that today we do not do any official announcements. So anything that you will see in this session shouldn't be taken as a reason for your investment or project decisions. It's for your information only. First of all, let's review what happened in the Cloud SDK recently. As you know, we are offering two main components of the client of the Cloud SDK, which is the Java library and the JavaScript library. And one of the biggest highlights that we are very proud of is that on the Java side, we already have a release of the OpenAPI generator, which is also the topic of today's session. Other than that, we delivered the new SCP workflow client library. You know that the workflow is one of the services that delivers its client library together with the Cloud SDK, so that you can use it out of the box with the new version. And last but not least, we are continuously improving the OData capabilities. In this case, we added some additional support for some new metadata fields that are introduced with OData version 4.0.1. On the JavaScript side, here again, we work hard on the OpenAPI client generator, which is in an experimental state yet. So if you decide to use it, please keep in mind that APIs might change. And if you want to work with stable APIs, then wait 1 or 2 more releases so that we declare it stable, like this is the case for Java. And another highlight on the JavaScript side, the Cloud SDK now supports parsing of multiple schemas in EDMX service specifications, which is basically on the OData support side. Over to today's session. First of all, I'll give a brief overview on how we understand client libraries in the SAP Cloud SDK and what the concept is. Most of you will probably already know it, but I want to give it as a basis so that we can move on to the demo that Matthias will give in the second part. And of course, at the end, you can ask your questions, or you can ask the question at any time in the chat here in this call, or later when you watch the recording in the comment field. Okay, let's talk about client libraries. Usually, if you're a developer and got a new assignment from the business department, they will tell you, okay, we want that you build an application that does this and that. And for your application to work, you will pull your data from a given system. But the business department usually is not very technical, as you know, and the best they will give you is probably the service in the API Business Hub, and of course the system that you should connect to. And for that, let's have a look at the Business Hub very briefly. We have shown this already in previous sessions. This is how the API Business Hub looks like. What we see here is a portal containing different SAP products that are listed here on the left. And one of them is, for example, S4HANA that I have activated now. And let's take S4HANA Cloud, which is this one here in the tile. And here we see that we have 419 listed APIs. And if I enter this system, for example, I have different tiles for every endpoint or every piece of API that this system offers. So here I'm seeing 12 of the 419 APIs. And for example, if I pick one, let's say activity type, it's getting more technical here. But the human understandable description is maybe this one, create, read, update, and delete cost center activity types, and so on. So let's not dive into the specifics here, but the idea is that this is our catalog of APIs. So now back to your developer assignment. Let's say you need to work with this service, with this API. And next thing every developer will ask themselves is how to get from this API that we just located to a Java class or to a JavaScript or TypeScript class. Because obviously developers like to code with classes, or they need to code with classes because this is how coding works. And for that, the Cloud SDK for Java and JavaScript offers the client libraries. So with help of the Cloud SDK, you can easily start working with this service that you located in the Business Hub and start writing code that works with this service. Now, this is the lucky case where you need to work with SAP S4HANA because if you remember, let's get back to the title page of the Business Hub. We have several SAP products here on the left, and I just clicked on SAP S4HANA Cloud. Actually, you see that it's also S4HANA here. And this is one of the systems that Cloud SDK already brings out of the box. So if you need to connect to SAP S4HANA Cloud or SAP S4HANA, which might be on-prem, for example, then you're good to go because everything you need to do is to include the SAP Cloud SDK client library into your POM XML or package.json, and you're good to go to start coding. Another example is, if you remember at the beginning of this session, one of our highlights was that we delivered a new client library for the SCP workflow service. This is another service that you can use out of the box with Cloud SDK. But if you see here, there is a lot of SCP products, right? So Cloud SDK does not offer client libraries for each and every piece of API in these products. For example, if I click on success factors, let's go to Employee Central. So here you see another, 21 APIs, another field class, another 155 APIs. So you see that there's a lot of them and it's quite dynamic. So it's hard for us to cover everything and to keep it up to date. And for this reason, we provide the tools that help developers to generate client libraries for themselves. Now, let's have a look at one of the SAP products, for example, Concur. Let's go to this one. Now, here I'm in a Concur API catalog, and it looks quite similar. but there is one main difference. If I click on one of the APIs and go to the details, I will see that actually here I have a REST API. And here is already the point. SAP S/4HANA offers mainly OData APIs, which might be OData v2 or OData v4. But the other systems offer REST APIs, of course. And actually, like REST is today's standard, more or less, for several products, and Concur is one of them. If we go back here, we see that on these tiles here that represent different pieces of API of Concur, we see that they have REST API, and so on. So if I want to work with this one, I have a hard time if I use the OData generator. For that, I need a REST generator, right? And this is the topic of today. In a few minutes, Matthias will demonstrate how this works with SAP Cloud SDK. Before doing that, I mentioned that Cloud SDK offers the tools, so the generator, basically. And if we go to Maven Central, I want to show you how exactly this looks like. So here I'm looking at the group com SAP Cloud SDK data model. This is the Maven group where we deliver our generators. And if I have a look at the modules here, I see some REST generator module, some OData v4 generator module, and down here is the OData generator. Of course, there are some other modules like you see. For example, we have the generator CLI, which is an executable jar file that can be invoked using the command line or packaged as Maven plugin. But all of them are actually variants of the REST, OData v4, or OData generator. So to remember here, the important thing for you is that these are the three main types of things that we can generate, both OData versions and REST. And they are packaged as CLI or as Maven plugins. And now I'll pass over to Matthias that will demonstrate how generation works with one of these packagings. And for that, let's go over to the demo. Over to you, Matthias.
Thank you very much, Jordan. Yes, it's always good to have a hands-on experience. So let me share the screen and take you through a bit. Maybe Jordan, you can tell me once you see it, and I think I have to somehow drag this.
I see it. Probably you should zoom a little bit. Increase font size, yeah.
Okay. Perfect. Thank you, Jordan. So as Jordan mentioned, of course, programming gets a lot easier when we have a generated API where we can access all the fields, all the methods, and so on and so forth in a convenient manner. It just reduces the effort, the development effort so much, and we can focus on the business value, what we want to achieve. And I want to take you through today a small demo of doing exactly that. And for that, we have a small test application set up here. Do this away. So what we basically have here is just a small application running, and it's serving like a small web shop. There are some items you can purchase there, and but that's not too interesting. We have a few controllers which already use Cloud SDK to perform some other stuff. For instance, if I look at the product controller here, it talks to S/4HANA to get a list of products, also with the Cloud SDK on an OData API. But that's not what we want to do today. Today, we want to increase or extend our application to also take into account promotions. And if you look onto the API Hub, you will find that there is price calculation service where you can calculate promotion prices by giving in a tenant. And there are all sorts of different things that we might want to do that we can get here. We can just calculate some amount, or also calculate an amount and perform an action. Or there are other things like you can get some links to some items, or even more advanced stuff like loyalty programs, like where you can collect some points or whatever for being loyal to your favorite store or something. So there's a lot of things that this service offers basically. And now the question is, how do we interact with it? And for that, let's use the Cloud SDK REST generator, the OpenAPI generator version, which will basically give us a client for this particular service. And I'll take you through how we can do this. First, let's look at the details here. And if you are logged in, as I am right now, you will see this nice button here smiling at you to download the API specification, which is an OpenAPI service specification. I can download it here, but I have already prepared my business application studio a bit so that we have it uploaded here. So you can, if you're not familiar with a business application studio, here you can actually upload a file. I think if I expand here, I've already done it. So this is now the API of this particular service, and there are different things, like here's this path that we just saw, and then later down here somewhere there are all the different schema definitions here that we will need. Of course, you could also now assemble some REST requests just based on this information here by hand, but that's not very convenient. So what does the Cloud SDK offer? We have basically an OpenAPI generator that is based upon the standard OpenAPI generator that you can obtain just from this open source project. And we have tweaked and configured it a bit to generate code that works with the Cloud SDK. And for your convenience, there are a few different ways how you can use this. Maybe I'll check out no, that's the wrong one, the documentation on it. Let me see here. There are a couple of ways that we can use it, but the easiest way, probably if you have a Maven project, is to just use the OpenAPI generator Maven plugin that we ship. This is convenient because you can just add it to your build process, and then you just have to keep the API spec up to date, and you will always have up to date generated code. And there are just some very basic things that you need to supply. So of course the generator plugin with the goal to generate simply, and then specify, okay, where is my input file, but also how should my package names be named, and maybe configure some log level. So really not anything too complicated, and I have prepared that already here a bit. So let me just comment this in. Into the POM XML file of our application, we would say, okay, this is our generator we want to use, the Cloud SDK REST generator Maven plugin. I think we could increase the version here to 3.36 if we wanted to. The input spec, we just uploaded here into API specs of this price calculation YAML. And yeah, the rest is just, we leave it just basically as is. Output directory just here in our source directory. And then let's run this. So this would automatically run if we would now run Maven install. But we can also invoke the generator explicitly. Let's do that for now. and it will, or it should pick up and then generate the sources here. And now we have a calculation API. So this is how you can conveniently use it. If you would like to not put this into your build process, there's also a CLI, which works basically, or which does the same thing, just you invoke it via the command line. Or you could even, if you wanted to, invoke the generator also directly via Java code. But I think usually the CLI and specifically this Maven plugin here are the most convenient ways to go. Okay, we also need one or two dependencies, which I've also already added. Let me just check. This one here, these two. The REST core is just a very small library where we integrate the Cloud SDK related stuff with this REST library. So we need that, and also some Swagger annotations, which are not so important. Good. Then now that we know how we generate this, let's see how we can use it. I've already prepared a stub here. We have called it promotion controller, and where we now want to calculate the promotion price. So let's see. We have now the calculation API. And I think I need to import that. No, that's not the one. Come on. I'll just then comment like this. Good. Come on. It should find it again once I built this project. Now it's not yet aware of that I added this. So this is how we would use it. We instantiate a new calculation API, and the API class will give us access to basically everything that the REST service offers. So all the endpoints that we can reach. In this case, I think maybe I'll run just the code in a moment so that we have also the IDE support here. Let me just quickly finish this. Like this. And there is one more thing which we need to give this calculation API. If we just jump here, which it needs, at least that's the standard use case, which is a destination. The destination is in the Cloud SDK a feature that basically describes how do I reach a target service, or how do I reach an endpoint. So in this case, what we would have to, of course, tell this API where does the actual service instance live, like a host we would need. We maybe need some login credential information, or where to get that from, how to authenticate, and stuff like that. Maybe additional headers that are needed to access this API. And so that is where we use the Cloud SDK destinations for. And let's check out how that would work out. I'll jump back here. So here we need some form of destination. And how can we get a destination? Well, there are a couple of different ways how you can do this in the Cloud SDK. Perfect, and now it also picked up on my classes. How you can do this in the Cloud SDK. For now, let's look only at the code that gives us the destination. We identify them by name, and we have this destination accessor here. And there we can just call get destination, supply a name, and then also say, okay, this is actually an HTTP destination. There can be other destination types, like for RFC or something, but in this case, we want to do a REST call. We have a REST API, so we want an HTTP destination. And now this API object here will be informed, will know how to target the service. And that is really all it needs to now fully operate. And again, we'll look at in a moment where this data here then of this destination by this name is actually coming from. So let's see what we can do. In this case, the API really doesn't give a lot of methods that are available, because there is basically just this one post endpoint that we have seen. Yeah, but that is what we are seeing here. Calculate via REST with tenant. And what we now have to give in is a tenant name. So for whom should we do the promotion price calculation? Let's just say in this case, we name it some tenant. Let's just assume this some tenant exists. And we also need a price calculate. I think in the most simple use case, we can say just new price calculate, and that would work. I think we could supply a bit more. We could supply alternative or more advanced objects here towards how this promotion pricing should operate, what it should do, and what it should return. Yeah, and this would already give us the result or the response, which would look like this. We would get a price calculate response, which then again has a lot of, or can have a lot of different information in it, as we saw earlier in the schema. For now, what we have done is already prepare such a small converter function here. And let me just also add this into our code and see what we are doing here. So this is now really the business logic, I would say. So what do we get in this case? We get here the body, of course, and then the shopping basket, and then we go over some line items and add a promo percentage value to our line items. To make sure all items in our shopping cart are simply promoted with the same amount, basically. So very simple use case, just applying some percentage to all our shopping cart items. But that's how we can then implement our business logic, essentially. With this, in the end, we can here just say we return response. Now returning this promotion response to whoever calls this mapping here in this case of our controller. But that is how, with relatively few code and especially relatively few infrastructure code, we can talk to a service. Now, one question that still remains is, how do we actually know this here? So where is this coming from, the destination information? In the end, we have to create this endpoint. So for instance, there are a couple of ways we can do it. One way is to create a destination in Cloud Foundry that points to our specific service, our specific system that we are talking to. So if this was an S/4HANA system, we would say, okay, this is the URL, this is the username, password, or the however you log in to reach it. But we could also put it into environment variables, or we could also even, if we wanted to, build it in the code ourselves. If I check default HTTP destination, it would have a builder where I could say my.target.service. Let's give it also an HTTPS, for instance. And maybe I say I also want to give this a name and now call it my destination .build. Of course, now without authentication, so we could even build this thing just in the code if we really needed to. Yeah, but usually the way that we would use it is just defining a destination in Cloud Foundry and maintaining the data there. That's here because also the destination service would take over some of the authentication related tasks. Good. Then I think let's run this application. Let me just install once and see that everything is fine and that we haven't missed anything. That looks all right. It's now also running tests, of course, because I didn't tell it to not run tests, but that is fine. Let's just for the fun of it run also our small web shop here. And then check it out. For the destination, we've now created just a mock destination that returns some mocked data. So in this was our small web shop here. So we like SDK for Java. Let's say we added 4 times to our shopping cart. And let's say calculate promotion. And I don't see anything. But that's okay. Maybe I didn't quite now from hand put up the code correctly.
Not sure if your tenant ID is actually existing.
Yeah.
This might be the reason for that.
That is a good point. Yes, thank you very much. I chose some random tenant ID. I think it now, of course, doesn't match the one that I think we had configured in our mock server. I think if I would switch it to the actual tenant ID, then I would get the correct thing. Yeah, and probably here I get an exception because I'm not doing any error handling here in this case. I'm just assuming this works, of course. And then if I get a 404 or something, yeah, then of course I get an exception here. So that is to be expected. Good. But I think we have an idea of how this is working. And yeah, that is basically already what I wanted to show. Maybe we can jump back to our slides, and then if there are questions, we could answer them in the Q&A after the normal session. Okay, Jordan, you may need to unmute yourself.
Yeah, this is what I was looking for.
Perfect, yeah.
A lot of windows here. Thanks, Matthias, for the great demo. So you not only saw how the generator works, it was actually a whole application built with the Cloud SDK. And for example, the whole destination handling, the way you saw it in this source code, this was also provided by the Cloud SDK. So this is another example of a client library or of a library that Cloud SDK offers out of the box. Yes, and for that we are concluding the demo part. And before we conclude the session and open up for questions, just let's summarize. So our goal with these client libraries or with the generator of the client libraries is, of course, that you can start coding and creating business values as fast as possible. Like Matthias mentioned, for REST endpoints or even for data endpoints, of course, you can do the requests by yourself and construct everything by hand, but this would cost you time and effort, and of course, you will end up with a lot of code that you simply could reuse. And this is what we offer with Cloud SDK. Our closing slide, later we will send out this slide deck to all of you. So here you will be able to click on the link. We created our documentation portal recently. That is our one-stop entry point for SAP Cloud SDK related things. So feel free to click on this link if you want to learn more. And on the right-hand side, in case you need to create an issue or ask a question or contact us, then feel free to use the GitHub issues. You find the GitHub repositories in the documentation portal, and the issues section is something that you are probably familiar with. So this is our communication channel, and by doing this, you directly can reach our developers so that you will be helped as fast as possible. And of course, if you decide to go over SAP community, then do not forget to set the SAP Cloud SDK tag, because otherwise we won't get the notification that some new questions were asked. Together with the slide deck, we will also include the link to the blog post that's related to this session, so that you can read everything there and also, again, see a step-by-step walk through everything that Matthias did. All right, this is the point where I say thank you for your time, for your attention, and let's open up for questions.
Yes, thanks everyone. And I think we have already one question in the Q&A tool. So just let me read it for everyone. If we are using a custom REST API and there's a change in the REST API, do we need to regenerate the classes again? And is there an easy way of doing this without touching any code? So maybe I just share again, and then we just look at this in practice. So yes, the way that we have configured our project here in the example with our Maven generator, now if we were to change the API spec, then automatically the generated code would also update. This can be a problem or can require, let's say not a problem, it can require that you also need to adapt your usage of the generated code, but that is because of semantic changes. So let's look at this in an example. So if I have my price calculation YAML here, let's say here would change something, the summary would change to summary, for instance, or whatever. So let's put some random stuff here, and we save this, and maybe we can compare with what it was before. So here it would have, I think, the method, and here it then puts the summary here and the description here. And so if I would now run Maven clean install again, this would update. This code here would update immediately. Does this require code changes or not? That depends really what updates. So if I just change the summary here, of course this doesn't have any impact on my coding, how I use it. This is fine. But if now, for instance, the let's say the method here would change, and it would say, okay, there is another required parameter like next to tenant name, also tenant ID or whatever, then of course you also need to update the code that's using it, because the API has changed. You need to adapt to the changes of the service. In general, when it comes to SAP services, there is some guidance towards how much services can change, and there's there are requirements for API to be stable. So, for instance, now this promotion API here couldn't just from today to tomorrow decide it completely changes how this API works. So it needs to stay compatible for a certain amount of time. And that is why if you're using code from the business API Business Hub, usually you might have some changes, but they shouldn't break the semantics and the syntax of the API. And as a consequence, also, at least as far as I am aware, the generated source code that you get out here also should not you shouldn't need to adapt in the usage. So this code here, this usage here should still work even after the API updates within certain limits. So if it goes up a major version, then usually there are changes required, but then usually you can target like V1 and V2. So at the same time, you're not your code doesn't stop working from today until tomorrow. I hope that answers the question. Let me know if I should explain a bit more in depth. Yeah, but if you really want to this generated code to stay the same, then you can also just use the CLI or exclude the code generation from the default Maven lifecycle. That is also a way to do this. Okay, there is a second question, which says running an app locally and connecting to an SCPCF destination for retrieving data from the system behind that destination seems to be supported in the SDK for JavaScript client, but are there any code examples for that? With running locally, meaning really running in your Visual Studio Code or your favorite IDE on your machine. Yeah, so I'm not exactly 100% sure about the JavaScript SDK if it can target destinations using the destination service from a local setup. I think the Java SDK at least cannot. I think because the authorization needed to talk to the destination service isn't done. However, you can mock the destinations in a local testing setting. So you could there are multiple ways to do this, but yeah, one way I showed earlier today. So you could have some test code that just uses the default HTTP destination builder and then puts here some test URL in maybe, or there we also have some util classes in the Java SDK, how you can load a destination. One way which we are also using, let me show this in a new terminal. Do I have it still here? Yeah. We just define it via environment variables. So in this case, here is our promo pricing, and here's the target URL where we would reach that service. And from the environment variables, this destination accessor here gets its information, and this can be useful for local testing because the SCP service isn't at least not easily reachable from localhost, basically. So what I would recommend also to make your project run very independently of any other test services is if you are testing locally, just supply some mock data via like wire mock or some endpoint that you mock for local setups that's very reliable. And then use like environment variables, or even better, there is a class, I think I don't have it on the class path now, which is mock util. Yeah, I don't have it right now. And there it has, this in the end has a method mock destination where you can in various ways supply a destination, and then it will be picked up by exactly the same mechanism. So your code can always look like this. Yeah, but you can supply destinations in various different ways. Okay, then I also just briefly saw a question on whether or not a project can have multiple consume multiple REST APIs, and yes, that is possible. I'm not quite sure how it's done with the Maven plugin. I think there we always expect one input file. Let me quickly check. Where do we have the here? Like this. Maybe in the future we could consider also taking in a list, basically. So the via the CLI, you can run the CLI, of course, as often as you want and include as much generated code as you like. That also works. Not quite sure. I think here it would be, so what is also possible, it also works with the plugin, but then you have to put this input spec here, remove it from here and put it into the executions. So I think here you can also put a configuration basically for each, for each execution, and then put this here, and then you can have like 3 or 4 different executions with different IDs, and then the plugin will just run 3-4 times, however much executions you put here, and take into account these different input specs. And probably you maybe also want to separate them then by package. So you maybe you want these 2 things then also to be here. I zoomed out. That was not what I wanted to do. To have them here as well, and that should also work. Are there any other questions? I'm very happy to answer.
So I think we're good, right?
Looks like it.
Great. So thank you everyone for attending the call. The recording will be made available in the SAP Community Calls page together with the presentation. Thank you, everyone.
Thank you everyone for joining.
Thank you.